All right, so welcome back. So we are going to continue now the material. So I just have a few more slides in here, and then we'll move on to probabilities. Yay. Let's start with the question on Zoom. Go ahead.
Is 11-point inter... I don't understand this. So there's a precision curve for only one query or averaged over multiple queries.
So I need to find the slides.
Is the
11
let
me look. Oh yeah, let me expand on that one. So there are two questions. So the first one, okay, so this one here is for just one query, right? But of course, it's one query, but you keep getting the next and the next and the next document, right? So you go down the list. So this is why there's multiple points, but it's just one query. What does it mean, interpolated? It means that if you do it on a data set that has 1 million points, like you have 1 million results, then you're going to have 1 million points in there. It's just not manageable. So what you do is that you interpolate and only pick like every 10%, for example. So this is why then you have something that just has 11 points, right? Takes less space. So that's the reason. Did I answer your first question? Awesome. Okay, so let's go to the second one.
The line for the awful search engine confuses me a bit. One never gets a true positive, and at the same time, there are no relevant docs in the collection. I would assume it simply stays close to 0.
Yes, this is correct. So let me expand on that, because that's true. I actually jumped quickly, but of course, that's very good to have critical thinking. That's exactly what we expect at ETH. So of course, when I say it's like this, it's not actually going to be 0 all the way, that's 0. What's actually going to happen if you look very precisely and have, let's say, 1 million of them, is that you do in fact start either here or here, but if already at the first results, you return something incorrect, you are already there. So that's assuming, okay, the first result is already there. Now, if I keep returning irrelevant documents, I'm actually just stuck here. So the question is, if I correctly understand you, how can it be that I still move to the right if I keep returning wrong results? That's your question, right? Yes. So what actually happens is that once in a while, you do happen to return something correct. That's basically what happens. And so basically, it means you go a little bit up and to the right, but then there are so many, again, incorrect documents that you go down to 0. Right? So it's really a bit like zigzags, right? But so close to 0 that if you zoom out, that's basically where you are. And in fact, if you actually did the interpolation, if you did this interpolation, then you will not even see the ups and downs. You will just see 11 numbers that are close to 0. That's what you see. Right? Did I answer your question? Yes, awesome. Need to adjust that because I'm speaking a bit with my nose. I have the feeling. Okay. There's the curve. We cross it. Okay, yeah, the ROC curve. That's the next thing I wanted to tell you about. Okay. What is this thing? It's not a precision recall curve, it's something else. It's called the ROC curve. I think, I'm not even sure anymore, but you can check on Wikipedia. I think ROC is for receiver operating characteristics. You can maybe check that quickly. It's actually an electronic thing. It's about devices, for example, for the network or network devices, or maybe a metal detector on the beach. Like you're looking for, I don't know, gold or whatever on the beach. And you have this detector that beeps, basically, when you detect something. So I like to explain this curve with a metal detector image, because that's easier to actually understand what's going on. So first, I'm going to tell you what we plot in there. We plot here the recall on the vertical line. So the difference with the PR curve is that the recall was here, but now we put it vertically. So that's the recall. And the other coordinate is not the precision. It is 1 minus the specificity. Right, this is what we plot. 1 minus, well, what does it do? It just takes the mirror, right? If you didn't have the 1 minus, it would just be the other way around. So it's really just a convention that it's done that way, but it's basically 1 minus the specificity, right? So the recall, remember, is about the false negatives, right? If you have a bad recall, it means you have false negatives. And the specificity is about the false positives, right? Okay, so now let's think about what this does. I lost something on the beach. I'm looking for it with my metal detector. And there is this little knob on the metal detector that basically allows me to adjust the sensitivity of it. But then maybe I don't adjust it well, and it's just never beeping ever, right? Even though there might be metal somewhere, it's not even beeping, right? Because I really put it to an extremely conservative parameter. So what's going to happen is that I have false negatives or false positives when it doesn't beep. It's a false, yes? False negative, exactly. It's a false negative because it should beep, but it doesn't. So what happens is that the recall has a problem. A recall of 1 would mean that it beeps every time there is a metal, right? But it doesn't. So it means my recall is not very good. So what do I do in that case? Well, I turn the knob, right? I have my little knob, so I just turn it and I just make it a bit more sensitive. And then maybe it's going to start beeping a little bit. So now my recall is no longer 0. It's going to increase the recall a little bit. But here's the problem. I might be tempted to turn it in more and more and more if I want a recall close to 1. But what's going to happen then? Yes? Exactly, false positives. That's what's going to happen. Then it's going to start beeping like crazy at every square centimeter of the beach, right? So that's the problem. So basically, what this little knob does is that if I turn it a little bit, it's going to start being sensitive and finding the metal. But if I turn it too much, it will find everything, but it will also beep like crazy. This is in essence what this curve does. Right. So, so this is where my knob is completely on 0. I'm not detecting anything. So there's basically false negatives all over the place, but never a false positive because it never beeps. Then I turn the knob a little bit. So now it starts beeping and beeping and beeping, but on occasion it might beep erroneously, right? So this is why it's going to the right. These are the false positives. And then at some point, if I continue turning the knob all the way, it will start beeping everywhere. So of course I have perfect recall because I find everything, but I also have a specificity of 0, which is because 1 minus, right? So the specificity of 0 is here, 1 minus 1. Okay, this is the ROC curve. Did you check on Wikipedia? Anybody?
Yes, it's sorry. Receiver operating characteristic curve.
Oh, I was correct. Awesome. Receiver operating characteristic. So indeed, this is where it comes from. But of course, if I tell you this is receiver operating characteristic in an information retrieval lecture, you're going to be like, you know, what is this? But this is just because it comes from that world, from electronics, right? Okay, and this also applies to machine learning, by the way. You can also do the same with machine learning. Okay, so this is actually a pretty good search engine, right? Because I don't have so many false negatives when I'm here, right? So I'm in that zone that I'm not making so many mistakes. If I were here, that would mean that I have a lot of false negatives because I have a low recall. If I'm here, I don't have a lot of false positives. And if I'm here, I don't have a lot of, sorry, I do have a lot of false positives, right? So these are the 4 zones, right? So these 2 zones I like to be in there because not a lot of errors, false positives, false negatives. And this is where I don't like to be, false negatives and false positives, right? What we love is a curve that basically goes like this, right? As you can imagine, a good metric given that curve is the area under the curve, exactly like we did for the precision recall curve, right? It's the area under the curve. So a good metric is that surface right there, the entire area down there. That is a good metric. So either you look at the curve you know, like if you want the details. But if you want just one number, you just take this area right there. Like potentially renormalize. Like if this is an area of 1 on the square, then you renormalize. Okay. So this is where you don't want to be, right? So this is a good search engine. That's fine. And this is an awesome search engine, right? You turn the knob a little bit and it finds everything and it's never wrong, right? This here is an awful search engine. But here's my question again. If I give you a metal detector that keeps beeping when there's nothing and it stops beeping when there is metal, do you like that metal detector? Yes? Exactly, that's exactly the idea. So basically you just turn it on and then you just wait until it stops beeping. And there's your metal, right? So this is why actually, this is really not so bad because you just invert the results. All right. So you can just turn it, just the 1 minus, right? This is what you don't want. This is the worst that can actually possibly happen to you. Is just garbage. It's just noise, basically. It just returns random bits and beeps or doesn't beep, but completely uncorrelated to the metal. Okay, this is just to scare you a bit. So this is there's so many metrics actually. This one is called normalized, discounted, cumulative gain. It's also about, you know, this mean, average, and so on. But I'm lucky enough that this is not a machine learning lecture, so I don't have to go in there, right? But basically, this is just to say that there's plenty of metrics out there, right? Okay. So other metrics that you want to consider, of course, these were only metrics about the correctness, right? But there are other aspects of the system that are important. There might be the performance, right? How good are you or how fast are you at constructing the index that you are building, the standard inverted index? How fast are your results returned? You probably noticed that the best search engines do it in just a few milliseconds, right? You have your results instantly, like Google and the like. You might have the expressiveness of the query language, which is when you type your results, how much can you express? There are actually many features that a lot of search engines have that actually many users are not aware of. But an example is that under Google, you can also type site : and then a domain, and that restricts your results to a specific domain, right? There's plenty of features like this that you can actually use. So that's the expressiveness of the language. And yes, of course, the size of the collection, right? So if you index the entire internet, like your Google, it's even more useful than on the size of a single library, right? And of course, every year that passes, we just keep getting better and better and better at these things, right? And by the way, we've been doing that in this lecture, right? The speed of index construction. We spent an entire week on that, right? Do you remember when I told you how we can construct in parallel, you know, across machines and so on? The speed of search, we considered it, right? That's the complexity. When you look up with your standard inverted index, you have your hash index, you have your tree index, so how fast can you look up a term? So we've considered this. Expressiveness of the query language, well, that's less the focus of the lecture, but we've looked into the Boolean query language, phrase search, you know, wildcards, and so on. And the size of the collection, well, we've seen all of these skills. All right. So I'm actually done with the evaluation. Do we have any questions? Anybody? Anything that wasn't clear, except the machine learning formula? Okay, on Zoom. Any questions on Zoom? I always have to give 1 minute, right? If I ask to give you the opportunity. Okay, so it doesn't seem there's questions. Of course, you can also ask them offline, you know, on Mattermost, send an email and so on. All right, so I'm going to stop here the recording for evaluation, and then I'll reactivate with the probabilistic part, right? So see you on the other side.